First, we are talking about hydrostatics. That means fluid is not in motion. We define pressure in this manner. We have got fluid here. Consider some area. Delta S. It can be inclined also. So let me make it more general. Liquid on the one side of that area will press the liquid on the other side of the area. That is just an imaginary area. So, pressure at a point is defined as the force that one side will apply on the other side, that will be equal and opposite force of course, divided by area. Pressure at this point will be, when you make this area, extremely small. So pressure at this point will be given by this limit. You already know the unit of pressure, Newton per meter square or Pascal, and you know that pressure is a scalar. When we talk about pressure at a point, it doesn't matter how we choose delta S. After all, delta S is approaching 0. Pressure varies with depth. That is a common observation that you can have. If you have done the swimming, you know it very well. So we are going to consider 2 points at different depths. We'll construct 2 areas. These are the 2 points separated by some distance. We are going to choose equal areas. Consider your system as this cylindrical volume. There is no physical cylinder there. We are just considering the liquid contained in that imaginary cylindrical wall. So this volume we are considering as our system. Consider the vertical forces acting on this system. The liquid above will push this downwards. That is just like your reaction, action reaction force, electromagnetic. And this interface, there will be a push up due to other liquid. And then of course there will be the weight of this. So there are three vertical forces we have. If I show the weight, it will become somewhat hodgepodge. Let me show it like this by a small arrow. So that's the weight. Let's say pressure here is something and pressure here is something. Let's say here it is at lower point it is maybe P, and the upper point it is P plus dP. Your common sense will tell you that at A pressure should be more. No problem, dP can be negative. This is delta S, this is delta S. So by this definition, this force will be P delta S, and this force will be P plus dP delta S. Applying equilibrium, we are considering hydrostatics. So there is equilibrium in the system. Net downward force equal to upward force. P delta S will cancel out. Let's say the density is rho, the mass is density into volume. Volume is this area which is delta S into this. Let's call this as dy. So maybe I can use here dm for little mass. dm is the mass in this. It's a small volume that we are considering. But when we integrate, we don't need to consider a small height. I mean, it can be a big thing also when we integrate. Cancelling P delta S, cancelling G dot there. Cancelling delta S gives us dps minus density into G into dy. We integrate. When we are integrating, we will generalize. Then this gap can be quite a bit, as much as we wish basically. So let's now picturize P1 here, P2 here, and H. So P1 to P2, 0 to H. This is the y direction I have taken. So P2 minus P1, rho and G are constants. That means P1 equals P2 plus rho GH. You actually already must be knowing this formula. It's just a formal derivation. So if you take 2 points at the same level, H is 0, so the pressure will be same. So in hydrostatics, there is no pressure difference as long as the height is the same, depth is the same. Okay? The next thing is Pascal's law. Pascal's law simply says that suppose you have some liquid and then you apply certain pressure from the top. Then this change that you apply from the top is transmitted everywhere in the liquid. So say for example, earlier this point was at certain pressure. Now you increase pressure from the top, so that change will be applied to that point also. Okay? It is simply transmitted everywhere. Now, you don't have to really mug it up. It does make sense. It does make sense from our previous discussion. Say for example, I consider 2 points, one on the surface and one here. Okay, let's say this is P1, this is P2, and this is H. So P1 will be P2 plus rho GH. Now I am going to increase P2. I change P2. But this law will still hold good. So how can it be that I change P2 and make it P2 dash? How can it work then? It won't work. That means P1 will have to change. H won't change. We are considering non-compressible liquid. Okay, H won't change. For our discussion, we are considering incompressible, homogeneous, non-viscous liquid. Incompressible, homogeneous, non-viscous liquid. So if I change P2, this law will still work. But then how can it be that both are correct? So if P2 changes to P2 dash, P1 will have to change to P1 dash. And whatever is the change in P2, same change will be in P1. For example, suppose P2 dash is P2 plus delta P. Then I have to put delta P here, there is no choice. Only if I put delta P here, it will make sense. Both will make sense. So actually it's a pretty obvious thing from our previous discussion. Pascal's law is a pretty obvious thing. Now just look at one interesting application. We want to lift the car. So this is some workshop car, and car has to be lifted. This area is, say, maybe A2. Then we have liquid here. Force is applied from the left side. Let's say left side area is A1. It's all liquid here. Let me call this one as F1, the left side force. Then the pressure will be F1 by A1. This pressure will get transmitted, Pascal's law. This gets transmitted here. So say due to that transmitted pressure this much, same pressure will be transmitted here also, but same pressure will not give us the same force because area is different. So let's say the transmitted pressure is giving us force F2 there. It will be in the upward direction, F2. So pressure transmission is the same, but F1 is not equal to F2 because areas are different. These two will be equal. These are pressures. F2 force is acting up, and that's how we are able to lift the weight of the car or whatever. So F2 that we are able to generate is F1 times A2 by A1. So what's the catch here? Catch is the difference in the two areas. You are able to get more force from less force. That may look like miracle. That's what is happening. You are able to generate more force from less force. Because you can choose A2 to be more than A1. You can choose A2 to be more than A1, so F2 will become more than F1. So with less force, you are able to lift much heavier car. Okay? So that's the concept of hydraulic lift. We play with areas. Of course, this is the explanation of the concept. Practically, there will be considerations like there will be a walls, etc. The three vessels shown in figure have same base area. Same. Equal volumes of a liquid are poured in the three vessels. Equal volumes, okay, that means actually this may look be higher. The force on the base will be maximum in A, maximum in B, maximum in C, equal in all the vessels. Yes, anybody?
Maximum in C. So because since base volumes are equal, height of C will be more. Since equal volumes are base area are equal and equal volumes poured in each one, so height will be maximum C. If pressure is rho GH, so pressure will be maximum in the bottom at C. So force will be maximum since force equal to pressure into area.
Shalvi, what about you?
So I think equal in all the vessels because area is not changing.
But same volume is poured. See this. Don't think that liquid is poured up to this side. Don't think like that. Equal volume is poured. If equal volume of liquid is poured, don't you think in this container liquid will go up to further height?
Yes.
So liquid will go up to the maximum height here, followed by this. Then this will be the lowest height. Suppose in this case liquid goes up to this height. In this case it could be maybe this much. And in that case maybe it is this much. Pressure depends on the height. It doesn't depend on the width of liquid. Sea and swimming pool. If water type is the same, it is the depth that matters, whether it is sea or it is swimming pool. Depth is what really matters. So depth, see the depth here. Maximum, medium, lowest. Pressure is maximum here, minimum here. Yes, anybody?
Option A, increase.
Anybody else? Why do you think it should be option A, increase?
Sir, because pressure, the atmospheric pressure inside the jar, it will increase. So pressure near the bottom is P naught plus rho GH. So
because of the air above you. Atmospheric pressure is because of air above you. It is because of the weight of the air. If you go inside a closed container, there is no atmospheric pressure. It is closed. Now think again. Okay, I will give you another clue. Pressure gets transmitted. So if something is open to atmosphere, let's say pressure here is P2, pressure here is P1. In fact, I don't need to take 2 points, only 1 point I need to take. So consider some point inside the liquid. And let's say this height is h. So due to this height, the pressure here will be rho gh, but pressure gets transmitted. There is huge air above, atmospheric air. So due to that, pressure here is P that will get transmitted. So pressure here will be P plus rho gh. Now that's a hint. In that question we are doing, there is no P but there is something else that you need to consider.
Sir, I think it should be option D, because initially air will, when air is going on being removed first, then the pressure due to air will decrease, so it will initially decrease. After that, when all the air is removed, then air outside will apply some pressure on the upper wall of the jar, and it will give some force on the.
The jar is closed. The jar is closed. Imagine a seal-packed jar. So outside air is non-existent. It will not be able to do anything inside the jar. Okay, so I will decrease is the right answer. B, option B for beta. And the reason is that think of this as atmosphere. Just think of this as atmosphere. That's it. This is completely outside. This is not doing anything. Above, outside the jar, whatever is there is of no use to us. Okay? So this air which is there, due to that there will be some pressure here. Due to that air, just like air above us has some pressure. So air above this air will have some pressure. Okay, so pressure here will be whatever is that pressure. It won't be P but whatever it is, P outside or whatever you call it, P plus rho GH, whatever. So as you draw this air out, obviously mass of the air will decrease, and the pressure of the air here is due to the weight of the air. If you draw the mass air out, its mass will decrease. So the pressure here due to that air will decrease. And if pressure will decrease, less pressure will be transmitted here. And therefore it will continuously decrease and decrease and decrease. Say for example this is vacuum. Then what happens? If this is vacuum, all air is drawn out. If all air is drawn out, then pressure contributed by the air is zero here. Then the pressure here will be just rho g this height. Rho g this height. That will be the pressure here if this is vacuum. Any clarification? Anything not clear? Let me know. Well, if it's a multi-story building, then if the tank is at the top, then in the lower floors, the water pressure will be more, right? H, because depth is more. So here, tank is at the top and the tap is 4 meters below it. So this is the water tank and this is the tap. And this is 4 meters. What is the density of water?
thousand kg per meter cube.
So that's it. That much Pascal. Manometer, as you know, is used to find the pressure of a gas. So this is your gas. Heights 2 and 8. This is 2. This is 8. And this side is open to atmosphere. Okay. So to find the pressure of the gas, we consider points at the same height. This point is at P gas. And this point will also be at the same pressure, same height. But here pressure is, due to this, plus, because this is open to ATM, PATM plus rho GH. So, it's mercury. And say we want the answer in the standard system, then what is the density of mercury, anybody?
Uh, 13,700 kg per meter cube.
H is this, which is 8 minus 2. Just simplify this. And see if you are able to get 1.09 exponential 5 Pascal.
Yes, sir, I'm getting the answer is 1.09 into 10 power 5 Newton per meter square.
The pressure of mercury at the bottom of U tube. Here. Well, that's rather simple. This is the height. You can do it either from the left side or from the right side, whichever way you like. Suppose you do it from the right side, it will be P ATM plus rho G, the whole H, this H from here to here. Just simplify this. And see if you are able to get that answer which I have written below.
Yes, sir, I'm getting 1.12 into 10 power 5 Newton per meter square.
This is the wider tube. Weight of the boy is given, mass of the boy is given. Find the difference in the levels of water in the two tubes. Okay. These 2 points are at the same level. They will be at the same pressure. Pressure here will be PATM plus rho G H pressure here will be PATM plus normal reaction due to the boy upon area. Normal reaction upon area will be the pressure here plus PATM. Consider boy as your system now. Boy is at equilibrium, so for him, if he applies N force on the piston, piston will also apply N force on the boy. Mg will be equal to N for boy system. So we have rho GH equals mg over A, big area, we want difference in the level, okay, H. M over A times rho, 45, 900 centimeters square. Density, it is water. Just calculate this. This should be the answer in meter. See if you are getting half meter as the answer.
Yes, sir, I'm getting half meter as the answer.
Very well. We stop at this point.